Now we're on 2021 AMC 10B, problem 17, right? So we have these 5 friends, Ravon, Oscar, Aditi, Tyrone, and Kim, and they're playing this card game where each person is given 2 cards out of a set of 10 cards numbered 1 through 10, right? So I can already see maybe Ravon gets like 1 and 2, Oscar gets 3 and 4, Aditi gets 5 and 6, Tyrone gets 7, 8, Kim gets 9 and 10, for example, right? And then the score of a player is the sum of the numbers of their cards, right? So like maybe in this case, we would have Ravon gets 3 points, right? Oscar gets 7, Aditi gets 11, Tyrone gets 15, Kim gets 19, right? So in this case, we get scores 3, 7, 11, 15, 19. But the problem says that the scores that they get is 11, 4, 7, 16, and 17. And then it's just going to ask us which of these following statements about who is given which card is true, right? So what I think for this one is that 1 through 10, right? What numbers can we get? We can get, if we add 1 and 2, we get 3, right? If we add 9 and 10, we get 19, right? So we can get any number between 3 and 19 like this. And the thing is, for each of these numbers, we can list out the number of ways, or the ways that we can put 2 numbers as summing up to that number. Like, I'll show you what I mean. Like, let's say Tyrone, right? Tyrone is 16, right? Well, we can figure out which pairs of cards he could possibly have that add up to 16, right? Well, let's say he has 1 as one of his cards. Well, then you get 15, which is no good because 15 isn't a card. If he has 2, he would get 14, but that also doesn't work, right? And we continue like this. 3, we get 13. 4, we get 12. 5, we get 11. None of these 3 work simply because we don't have any cards with a value greater than 10, right? But then once we get to 6, we see the first solution that works, right? 6 and 10. And then we can say, let's say he has a 7 card. Then he would get 9, right? As his other card. However, this is very important for solving the problem. And in general, like other problems, there's usually an exception. And in this case, the exception is if we have 8 like this, even though both of the numbers are under 11, it's between 1 and 10 like that, they're the same number. And the thing is, each person is given 2 cards out of the set 1 through 10. So you can't get 2 of the same number. There's only 1 of each. So we can't have 8 and 8 like that. So we know that it's false, right? And now we could try, let's say he has 9, right? Then he'd get 7. And if we get 10, then he'd have 6 as his other card. And what we realize is that 6, 10, and 10, 6, they're the same thing, right? Since we're adding the 2 numbers, it doesn't matter what their order is. And they're still getting the same 2 cards. So this doesn't matter, right? So 9, 7, 10, 16, they're just the same thing as these 2 solutions, right? So let's say for 16, we get the only 2 solutions are 6, 10, and 7, 9, right? So this is what we get for 16. I'll just erase the ones that didn't work. And we can see it for the other numbers as well, right? Like, let's say we try, Kim has 17, right? Well, if Kim has 17, we do the same thing, right? We'd start with 1, we'd get 16, and we'd work our way up from 1 to 6, right? And none of these work simply because the numbers are greater than 10. And what we get is we'd have 7 and 10 here. This is the first solution that works. And then we get 8 and 9, right? So we do the exact same thing that we went over for 16 to get 6, 10, and 7, 9. And those work, right? And if we do this exact same thing for 17, we'll get 7, 10, and 8 and 9 work, right? Next, maybe we'll try 7, right? Aditi gets 7. Well, 7, we get 1, 6, 2, 5, and 3, 4, right? After we go on past 3, we're going to get to 4, and that's just going to start repeating solutions, right? So we can stop at that point. And then we can try 11 or 4. Let's just try Oscar, right? And this gets to the main point of the problem. When we try 4 for Oscar, we're only going to get 1 and 3. Nothing else. We can't get 2 and 2 because 2 is the same as 2. We can't draw 2 of the same card. So there's only one solution to this 4, 1 and 3, right? And then this is going to come in handy. Just 1 second to go over the 11. The 11s end up being actually every single card works. 1, 10, 2, 9, 3, 8, 4, 7, 5, 6. Okay, so now back to this. We have one solution for 4, which is 1 and 3, right? Well, that means we know that Oscar had to get the 1 card and the 3 card. That means that all these possibilities here for the other 4 people, they all cannot have a 1 or a 3 in them, right? So let's just go with 11, right? 11, we have to cross out this 1. The 3 and 8, we have to cross out this one because it uses a 3. These two never use 1s or 3s. And then for the 7, we have to cross out this one because it uses a 1. And this one because it uses a 3, right? So now we realize this is kind of like a linear fashion. After we realize 4 has only one solution, and we get rid of the other 2 solutions for 7 that have a 1 or a 4 in them, we find out that there's only one solution for 7, 2 and 5. So now we know Oscar got 1 and 3, and Aditi got 2 and 5. So now we can cross out these 2 solutions from 11 because they use a 2 or a 5. So now we're left with 11 only having 4 or 7. So Ravan had to get 4 and 7. And now let's look back at the problem, since now we've given out the 3, 4, and 7 cards. So we know we're already going to be done because these problems are all about who got the 3, 4, 7 card. So since we've already gotten who got 3, 4, 7, we can solve, right? Well, did Ravan get card 3 or did Aditi get card 3? Well, no, the 3 card went to Oscar, right? Who did the 7 card go to? Well, it went to Ravon. So Tyrone did not get card 7. And then we have C and D, right? Who got card 4? Well, it turns out Ravon got card 4, which means that the answer is C. Okay, next we have AMC 10B 2021 problem 18, right? So we have this fair 6-sided die, and we're going to repeatedly roll it until an odd number appears. So what is the probability that every even number appears at least once before the first occurrence of an odd number? So what is this problem really saying exactly? Well, let's say we start rolling a 6-sided die, and we're just going to keep on rolling it, right? So we're going to maybe get like 1, 2, 3, 4, 5, or 6 each time, right? Well, maybe the first time we roll it, we get 2. Is 2 an odd number? No. So we don't stop repeatedly rolling until we get an odd number. So maybe we would get 2, and then we'd roll 4, I don't know, and then 5, right? If we roll 5, 5 is an odd number, so we're going to stop rolling. Notice this doesn't mean that we're not going to include the 5 in our list of rolls. No, 5 is our last roll, right? So we get the sequence 2, 4, 5. And it's pretty easy to note that it's always going to be a sequence of evens that ends in an odd, right? It's going to be like even, 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 so on. And then we're going to have an odd at the end. Because once we get that odd, it's going to stop, right? So what this question is asking for is the probability that after we finish rolling, right? Like we finish rolling after that 5, what is the probability that every single even number appears at least once? So in this chain, we have to have at least 1, 2, at least 1, 4, and at least 1, 6. Well, let's look at this sequence. Do we have a 2? Yes. Do we have a 4? Yes. Do we have a 6? No. Right? So that means that the sequence will fail. Now, what's an example of a sequence that would work, right? Let's say we get a 4, and then we roll a 6, and maybe a 4 again, it doesn't matter, and then a 2, and then we roll a 3, right? In this case, the sequence would work because we have 1, 2, we have 1, 4, and we have 1, 6. And actually, the thing is we actually have 2 4s, but It just says at least once, not exactly once. If it said exactly once, then this would fail because we have 2 4s, but it says at least once. So we can have anything from 1 or greater for each of these, right? So what I'm thinking about is in this problem is, what is an example of a longer, I'm going to think of like a longer dice roll and try to visualize how we can calculate the probability, right? So let's just pick a longer roll, right? So let's try stretching out, like let's just say 2 4 6 1. This is like the shortest sequence that we still get 2 4 6 and then an odd number, right? Well, let's try to think, what can we put in between these numbers to get like a longer thread, right? A longer sequence of rolls, right? That could also happen, and it also works. And let's try that, right? So we roll a 2, right? Well, we could also roll a 2 again, and then again, and then again. It doesn't matter, even though this is very unlikely. We're just trying to extend this roll out. Like, we're going to see what is like the core of what this sequence of rolls is and its characteristics. So we can roll 2 as many times as we want, right? It doesn't matter. But then after that, we're going to have to eventually roll a 4, right? And we can't roll a 1, a 3, or a 5, right? We can either roll a 4 and a 6, right? But in this case, we're rolling 2, 4, 6, 1. So let's just roll 4, right? Now, after this 4, we can roll any sequence of 2s and 4s. It doesn't matter, right? 2, 4, 4, 2, 2, 2, 4, 2, 4, 4. It doesn't matter. It doesn't matter what 4s and 2s come after it. All that matters is that the next integer we get is going to be a 6, right? And now after we get the 6, we're done. It doesn't matter what comes after this or when we stop. It doesn't matter if after this we just immediately get a 1, right? Or if we get a 3 or a 5, or if we just have this random string of 2 4s and 6s until like a million numbers later where it finally ends with a 3. It doesn't matter, because we've already gotten at least 1 2, at least 1 4, and at least 1 6. We have a 2, a 4, and a 6. So it doesn't matter what happens after that. We have a 2 4 6. We're done. This is something that will work. It doesn't matter how it ends. So how can we describe this, right? How can we put this into like a product of fractions, for example, right? Well, what is the probability that we roll an even number first, right? Because if we roll an odd number first, it's never going to work because we're just going to stop there, right? So we have to roll a 2 4 or 6. The probability of that happening is going to be a 1 out of 2 chance. 2 4 6 out of 1 2 3 4 5 6, right? And now after we roll that 2, we can keep on rolling 2s. It doesn't matter how many 2s we roll after that. But all that matters is the next number that is not a 2, right? Or if we started by rolling a 4, we're just going to keep on having 4s. It doesn't matter until we have the next number that's not a 4. So what is the probability that this next number that's not a 2 is going to be even, right? Well, we can either roll a 1, a 3, a 4, 5, or a 6, right? In order for us to not get a sequence that fails, we can't have a 1, 3, or 5 yet. Because if we do, then the sequence would terminate, and all we would have is some 2s, followed by the sequence ending due to an odd number. We would only have one of the 3 even numbers. So we can't have 1, 3, or 5. But then we look 4 or 6. Well, both of them could work, right? Because if we have like 2, 2, 2, 2, 2, right? Maybe, and then we have 6 instead of this sequence, that also works. If we have 6, then after that sometime, we could also have a 4. So it works regardless of the order. As long as we have 1, 2, 1, 4, 1, 6, it works. So 4 and 6 work. So out of these 5 possibilities, exactly 2 of them work, right? And now let's just look at the string of 2s and 4s afterwards. But keep in mind, it doesn't matter how many 2s and 4s we have after this. All that matters is this next number that's going to be not a 2 and not a 4, right? We can have even up to like a billion numbers that are just 2s and 4s. But after that, we're going to get a number that's either 1, 3, 5, or 6. And what we're looking for is for it to be a 6, right? Because the thing is, if it's not a 6, it's going to end prematurely. We're going to have 1, 3, or 5, and then we're only going to have 2s and 4s, and then it ends due to an odd number, right? So we need to have the 6 here, which is only a 1 out of 4 chance. And notice this works for any permutation of 2 4s and 6s, right? Like let's say we have 6 4 2 2 2 4 6. this too, right? We have a 6, we have a 4, we have a 2. These don't matter, right? The probability of this happening, 1 out of 2, 2 out of 5, 1 out of 4, right? So the probability in total, we just multiply these fractions together. And we cancel, 2 cancels, and 1 times 1 is 1, 5 times 4 is 20. We get our final answer is 1 out of 20. Okay, so next we have this number here, problem 19, and it's giving us this finite set of positive integers s. And it's saying if the greatest integer in s is removed from s, then the average value of the integers remaining is 32. If the least integer in s is also removed, which means we're getting rid of the least and the greatest integer, then the average value will be 35. And then if the greatest integer is returned to the set, the average value rises to 40. And what it's saying, it could be confusing. You could get lost in this paragraph of words. What it's really saying is if we put in the least and then the greatest, and then we take out the least, then we take out the greatest, but then we return the greatest, right? If we take out the greatest and return the greatest, that makes no change. So really what this last sentence is saying is if we only take out the least integer, then the average value would be 40. So we have this set S, right? So let me just draw out a diagram that shows S. Right, so what we have is that the least integer is going to be n, right? Let's just say it's n. Well, we have this last sentence here. The greatest integer in the original set S is 72 greater than the least integer. So this greatest integer here is going to be n plus 72, right? So we can get rid of that S thing now. We have some n. We have n plus 72 as the greatest. And we're just going to assume this list is in least to greatest order, right? And now we're just going to have some random integers in here. I don't know what the integers are or how many of them are, but what really matters here is averages are really some amount of integers, right? The sum of like n integers, for example, over the number of integers in that set, right? So in reality, what we want is the sum of these integers here and how many of them are, right? So those are the two values that we really care about. So what I'm going to say is we're going to say the sum of these integers here, just this blob here, it's going to be S. And the number of integers is going to, in this set, not including n or n plus 72, is X, right? So now, with these set in place, we can set up our averages, right? So if the greatest integer in S is removed from S, then the average value of the integers remaining is 32. So what this is saying is that we take the average of these numbers, right? We're not taking the average of n plus 72 included because we're taking out the greatest integer. So how many integers are here? Well, there's x, right? X integers in that blob, plus 1, right? So we have x plus 1. And what is the sum of those integers? Well, the sum of this is s, and that is the value of it is just n. So s plus n. So this is equal to 32. And now we can do the same thing with if the least integer is also removed, right? Least and greatest. So we're only taking the average of these numbers, right? And that is just s over x. And that's going to be equal to 35. Now what we get is that we have if we add back in the greatest integer, then we're taking out the least, right? So we're taking this set right here. There's still x plus 1 integers, but unlike here, we're going to have s plus n plus 72, right? Instead of s plus n. And this is equal to 40, right? So now we have the system of equations here, and we have 3 equations and 3 variables. So you can already tell it's going to be a solvable system of equations. And what I see from here is I want to take we can just solve the system of equations no matter what. But what I'm going to do is I'm going to try to look for shortcuts, right? Well, what's the easiest number to solve for right now, right? Well, the thing is, we have s and x, right? So either s or x. We should solve for s or x because we have this really easy ratio here, right? And now I see in these two formulas, s is combined with n, which is something I don't want. But what I do see here is that the difference between these two numbers here, if we take the difference between the right-hand sides, we get an integer. And if we take the difference of the left-hand sides, we're just going to get something in terms of x, right? So we can just subtract the two equations and then solve for x. That's going to be probably the easiest shot at solving a variable we have right now. So let's subtract these two equations. S plus n plus 72 over x plus 1 minus s plus 1 over s plus n over x plus 1. If we subtract those two, we're just going to get 72 over x plus 1. And then if we subtract this, right, 40 minus 32, we get 8. And what we solve from this is that we multiply by x plus 1 on both sides, divide by 8. X plus 1 is equal to 9. And what this is saying is x is equal to 8, right? So now I'll plug in, and what I notice is that x is in the x plus 1 is in the denominator of each of these fractions. So I'm just going to plug in x is 8 and then multiply by x plus 1 or x in each case, right? So in this case, for equation 1 here, right, equation 1, we get s plus n is equal to 32 times, and then what's x plus 1? X plus 1 is 9. 32 times 9 is going to give us 288. What we get from the second equation, equation 2, is that s is equal to 35 times 8, which is x. So 35 times 8 is 240 plus 40, which is 280, right? And now we have that if we have this equation, we get, well, s plus n plus 72 is going to be equal to 40 times 9, which is 360. So now we have these three, and let me just clean this one up. It's just 288. So now it's going to be really easy to solve, right? So let's just look back at the problem and see exactly what it's looking for. What is the average value of all the integers in the set S, right? Well, remember, S has n. It has n plus 72. And then it has this mix of integers in the middle. And there's x of those integers, and their sum is s, right? Well, what we're looking for is the sum of s, n, and n plus 72, because that's the sum of all the integers in the set. And then we put it over the number of integers in the set, which is x, right? There's x integers here. Then we have another 1, and then we have another 1, and we have plus 2, right? So this is what it's really looking for. This is what the answer is, right? And what I see is x plus 2. Well, that's just 10. So we're just looking for 10, right? So s plus n plus 72 over 10. And what I immediately see here is that if we add these two and subtract the third, we're going to get 2s minus s, which is just s, plus n plus 72. So the answer that we're looking for is 360 plus 288 minus 280, because that gives us this numerator here. And then we put it over 10, right? And then if we add all of this up, what we're going to get is 368 over 10. And our answer is going to be 36.8.
Now we are solving problem 20 from 2021 AMC 10B. So these geometry problems looks very complicated, but let's take a look at 11 lines segments, each of which has two length of 2. Okay, let's put this into the 2, 2, 2, 2, 2, 2, and then you observe that something nice triangles, which we call equilateral triangles, are happening, right? Okay, we will get back to them. The area of pentagon, yes, that's technically we are looking for the whole area of the pentagon. Okay, since we observe that there is here in the 60 degree, 60 degree, and 60 degree, 60 degree, and we are seeing that here also 60 degree, right? And what we can do, I am thinking that to remove these complexities, what I am thinking that I can connect point A to point C and point A to the point D. So let's see how this help us. Yes. Okay. Now we have, and then once you connect this, what do we see that is there is another 30 degree, because since this is an isosceles triangle, and then 30 degree, and here also 30 degree, and then 30 degree. Okay. Can I find, okay, one thing I would like to tell, if you have a triangle, let's say, with 120 degree, and what we say that this is A, and this is A root 3, A times root 3. Then the second thing, so I'm, okay, then we can say that this, the length is going to be 2 root 3, and then this one is also 2 root 3. So we will see that this will help us a lot. So that now we have technically 3 triangles. So now I don't really need this part. Really, just let's get rid of this part and make clean everything nice. You see that? Now I just need, I can put this back to 120 degree here and 120 degrees. So I have 2 identical, 2 congruent triangles, 30, 30, 120 degree, and there is one isosceles triangle, 2 root 3, 2 root 3 here, and this one is going to be, okay, then so the green triangle and the others too. Okay, let's see. So first thing, I can find the area of the green triangle here. So how do I find the area of green triangle? Let's see. 2 root 3, 2 root 3, and then 2. I need attitude, right? I need to get height of this triangle. That is going to be, I like this one. It is just angle, so the length bisect, and 2 root 3 square, 12 minus 1, that is going to be root 11. Then the area of this green shape, the green triangle, would be 2 times root 11 divided by 2, cancel, and root 11. So this is the area of this green triangle. So we got this one. Then how about the area of these two triangles? So I can think of this is, okay, that's one. If I find, or I can even connect, let me just connect these two together. I like to do that way as well. So here is the thing. I can think that this is going to be, okay, so this is 120, 120, 2, 2, 2, 2. Technically, this is two triangles, right? This is 60, 60, 60, 60, 60. So technically, this is two equilateral triangles. Then what is the area of one equilateral triangles? A square root 3 over 4. Then area becomes 2 square root 3 over 4. Cancellation. So and root 3. So the area of this part is root 3. Area of the part is root 3. Then what are we looking for? So this is root 3. It's technically, or you can do it the other way, but still the same. And root 3 and root 11. Then how do I express this? Let me just express this one here. Root 11 over 2 root 3, which means little algebra, radical knowledge. So you put number 2 inside the radical. So that means root 11 plus root 12. Then this is my m. That's okay. Then m plus m becomes 23. So that's end of the problem 20 from 2021 AMC 10B.